Welcome. We are Group 1 and this is our data science salary analysis. This analysis explores salary trends in data science, the impact of experience levels, and employment types. The dataset contains a total of 46,637 rows cleaned records, focusing on job titles, salaries, experience levels, company locations, and employment types. Let's move on to the objectives of this project. So the objective of this analysis, firstly, analyze salary trends and insights within the data science industry based on job titles, experience levels, employment types, and geographic locations. Second, identify key factors influencing salary variations such as experience level and employment type. Third is visualize data using various charts to provide a comprehensive and understanding of salary distributions and trends. Lastly, for the objectives, offer insights that can help IT students and professionals make informed career decisions. Let's move on to the overview of the project. This project explores salary trends in the data science industry by analyzing a dataset containing job postings with details on job title, salary, experience levels, company locations, and employment types. The dataset underwent thorough cleaning to remove duplicates and missing values, ensuring accurate analysis. The study identifies salary distributions across different roles, experience levels, and employment types, offering insights into how these factors impact earnings. Various visualizations, such as tree maps, bar charts, and scatter plots, illustrate key findings, helping professionals and understand market trends and make data-driven career decisions. And after discussing the overview, we move on now to the techniques used in this analysis. First is data cleaning and processing. In data cleaning and processing, we remove duplicates and missing values, selected relevant columns, and converted salary data to numerical format. Next techniques are ex- exploratory data analysis. Here in exploratory data analysis, we calculated salary distributions, identified common job titles, experience levels, and employment types, and also examined salary correlations. The last techniques used are data visualizations. This is where we use tree maps, bar charts, box plots, stacked bar chart, scatter plots, and the mean salary bar charts to illustrate salary trends.
So I'll be talking about the in-depth process of the data cleaning and processing we did. The dataset was cleaned by removing duplicates and missing values. Only relevant columns such as job title, salary in USD, experience level, company location, and employment type were selected. Salary data was converted to numerical format, ensuring accurate analysis. The dataset maintained over 500 rows after cleaning, preserving meaningful insights. The original value of rows went from around 90,000 to 46,637. So let's talk about the relevant columns we used. First is the job title. This column represents the role or position for which the job posting is made. The unique values printed here might include roles such as data scientist, machine learning engineer, data analyst, and etc. These roles help us understand which positions are available and how the salary varies between them. Next, salary range. Although stored as a numeric value, this column represents the compensation offered for the job. By printing the minimum, maximum, and mean salary, we get an idea of the overall salary distribution in the dataset. It may include a wide range of values that help in identifying the lower and upper bounds of the current market offers. Next is experience level. This column indicates the required or actual experience level for the role. The unique values here might include terms such as junior, mid-level, senior, or coded values like EN, EX, MI, and SE. This helps us see how experience correlates with salary or compensation. Next is employment type. This attributes specifies the nature of the employment contract such as full-time, part-time, contract, or freelance. By inspecting the unique values, we understand the diversity of job contracts in the dataset, which is useful for comparing salary trends across different types of employment. Last is company location. This column provides the geographic location of the company offering the job. The unique values may include various cities, states, or countries. This information is crucial because salaries can vary greatly depending on the cost of living and regional market demands. For the data cleaning code use, we use first is df that drop duplicates in place equals true, removes duplicate rows from the dataset to ensure unique entries. Next is df the drop na in place equals true, eliminates missing none values to maintain data integrity. DF equals DF job title, salary, expense level, company location, employment type, which is the columns, selects only relevant columns for analysis, removing unnecessary data.
Salary trends and insights. Salary distribution by job title. Certain roles like machine learning engineer and data scientist have higher salaries than others. Box plots indicate salary variations within the same job title due to factors like experience and location. Salary and experience level. Senior roles earn significantly higher salaries compared to junior positions. Entry-level positions have a lower but stable salary range, while mid-level roles show more variance. Employment type distribution. The majority of jobs in data science are full-time, but freelance and contract positions still exist. Salaries tend to be higher for full-time roles, where contract and freelance positions show variability. Employment type. FT means full-time, PT means part-time, CT means contract, FL means freelance. Experience level. EN means entry level, ML means mid-level, SE means senior level, EX means executive expert level. Next, correlation and findings. Experience level versus salary. A positive correlation was found between experience and level and salary. This confirms that more experience generally leads to better pay in the data science industry. Geographic influence. Although not explicitly plotted, salaries may vary significantly across locations due to cost of living differences.
Now moving on to our experience level distribution. For this visualization, we used a tree map showing the distribution of experience levels in the dataset. You'll notice that the majority of professionals are in mid-level and entry-level roles, while executive positions are the least common. This suggests that data science is a field with a higher proportion of early to mid-career professionals. Next is the employment type distribution. We have another tree map, this time showing employment types. As expected, full-time roles dominate, while freelance and contract jobs make up a smaller portion. Part-time positions are the least frequent, which tells us that most companies prefer full-time data science professionals. Next is the top 10 job titles. Here we have a bar chart displaying the 10 most common job titles in a dataset. Data scientist, data engineer, and data analyst are the most frequently occurring roles. This highlights the demand for core data science expertise. Specialized roles like analytics engineer and research scientist appear less often, but may offer higher salaries. Next, we'll talk about salaries. Our box plot and distribution plot reveal a wide salary range, with some significantly high salaries indicating lucrative positions. The right skew distribution shows that while most salaries fall within a moderate range, a few high earners pull the average up. Moving on, this stacked bar chart categorizes the most common job titles per experience level. Entry-level professionals mostly hold data scientist and data analyst positions, while mid-level employees transition into a mix of technical and managerial roles. Senior and executive roles are where we see leadership positions like head of data and chief data officer.
Salary versus experience level. This scatter plot shows the relationship between salary and experience level. As expected, salaries increase with experience, but we also see some overlap. Not all mid-level professionals earn less than senior employees, other than factors like industry and specialization influence earnings. For the salary versus employment type, so here we examine how employment type affects salary. Freelancers and contract workers have more variability, with some earning exceptionally high wages like due to specialized skills. In a while, full-time employees have more stable salaries and part-time roles tend to pay the least. Salary distribution by experience level. This distribution plot shows how salaries are spread across experience levels, while the bar chart highlights the average salary for each level. Executive level professionals earn the highest salaries, followed by senior and mid-level employees. Entry-level salaries are significantly lower but still show some variation. Top 20 highest salaries by job title. Finally, this bar chart lists the top 20 highest paying job titles. We see roles like AI engineer, machine English learning scientist, principal data scientist leading the pack, emphasizing that the specialized skills in AI and ML are highly valued. Leadership positions such as Director of Data Science are also ranked high. Before we wrap up, here are some possible next steps for further analysis. We could look at the salary variations by region, compare salaries across industries, or even investigate gender pay gaps if the data allows. In conclusion, more experience leads to higher pay, important for IT students planning their careers. Job titles matter. Some roles offer better salaries than others. Employment type impact earnings. Full-time roles tend to be more stable, while contract and freelance roles may offer flexibility. Future improvement. Adding cost of living adjustments could make the salary comparisons even more accurate.
Thank you for listening. That's all for our presentation.